Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are at lecture number 42, learning about projection of solids. Let us take an example. A triangular prism placed on horizontal plane. If that is the case, how these views really look like on vertical plane and horizontal plane. For example, this is the triangular prism having apex and axis. Now, if one of the base edges, for example, maybe this one or this one or the other one of the base edges parallel to, when we are looking from top view, this entire point shrunk to this single point apex, and we will be in a position to see these edges also, those three edges. So, that is the reason we have these continuous lines. Now, if we are looking from top view, it looks like a triangle, and if we are looking from a front view, because one of the edges is parallel. So, if we are looking from this side, this supposed to be visible, this one also supposed to be visible, this one also supposed to be visible, and these lines intersects at this point. Because this is a parallel one, this entire line, this line, the edge line all the time maps. So, this one always be maps, this one always be maps to that line. So, what we will see is the frontal one, a continuous line, this entire line goes all the way to apex, and this entire surface maps as this surface. So, we will see a triangle, it is a surface. Similarly, this entire surface maps to this entire surface, and we will see another one. Naming always be, in the top view we will have without primes A, B, C kind of things. In the front view we always have primes A prime, B prime, C prime and so on. Let us rotate this one of the base edges. So, instead of having this one, let us have a inclined prism. In that case, from the top view, this point A maps there, B and C coincides, that is the reason B prime C prime, O will be visible, and there is a line which goes and joins that point. So, all the way from there we connect it by that. There are multiple, if multiple points are there, one of the point we will show outside, invisible point or mapped point which is at back side, we will show it within the parenthesis. So, here if we are looking from this side, B point will be visible, that is the reason in the front view it is B prime, but C point will be at back side of that, invisible. So, within the parenthesis we will show. Similarly, O point and O prime, in the top view O1 is invisible, because it goes all the way down of that prism somewhere here O1. In the top view this is the O. So, when we are looking at this in the top view, O will be visible, O1 will be invisible. Similarly, when we are looking from front view, O point goes to O prime, in the front view always be having primes, and O1 prime, which is that one, invisible. So, we show it in parenthesis, and this axis one all the time mapped to dash dot lines. Now, instead of having this B point and C point coinciding, we slightly make an offset. So, the slightly rotate this in this direction. If we do that, B will be visible, it goes, and from B there is a line which goes and joins the top apex, that one will be this one. In this case, C, BC surface also visible. So, we will have this surface. Similarly, in the front view, this ABO surface will be visible. So, A prime, O prime and B prime surface. This O1, O prime, O1 prime, O1 prime is invisible, O prime is visible. That is the reason we show it by dash dot line. Because it is slightly inclined, so naturally this line whatever it is going to join, that will also be inclined. Now, instead of asking this base edge parallel to vertical plane and near to vertical plane, what we will ask is, if this base edge is parallel to vertical plane, but far away from horizontal plane, where this one will be near to that. If that is the situation, we will have A, B and C will be in that way. Same thing, if we are projecting the lines, it goes to A prime, this one goes to B prime and O goes to O prime. This entire surface will be visible. So, this entire surface will be visible. These back side lines we can't really see, that is the reason we show it by dashed line. If you note it carefully, here the OO1 supposed to be dash dot lines, but the object dimensions are more important than that axis in this case. So, that C all the way from O to C, whatever invisible line, we show it by that dashed lines. So, we do not show that axis and give preference more for this invisible dimension than for the axis. Now, let us begin with one more example, a cylinder resting on horizontal plane, but maybe its generator is resting on horizontal plane. Instead of having the first example like resting means vertical cylinder, what we will see is a laid down horizontal cylinder. For example, here we have this vertical plane and this is the horizontal plane, and our cylinder perhaps resting in that way. This is the horizontal plane and this is the vertical plane. When we are looking at that, it just touch at these points, the line whatever it is joining, there only it touches, remaining points will not touch the generator. So, when we are looking in that direction, horizontal plane, rotate it, we will see it like a rectangle. And this one maps to a circle in that way, and it touches only at one point, a point contact you will have. So, along that line, if you are looking in the front view, it will be a point. and axis always be dash dot line, and you will have O point and O1 point. So, those will be O prime and O1 prime here. Now, if a cone is resting on a horizontal plane, is not resting on base, but on its generators, then anyway in the top view, if we are looking at it, it will be a triangle. Because it is a cone which is resting on the horizontal plane, this apex point always touches the ground, and that one is this. When you are looking from this direction, though it is a cone which is inclined, but because of this projection we always see everything mapped to a circle. Is a right circular cone, that is also one of the reason we will see only circle. This point is on the base on horizontal plane. That means that entire line, generator lines which are inclined in the vertical direction, that when we are flipping it in that direction, that entirely coincide to that point. Similarly, if you are looking at a prism perpendicular to vertical plane. So, axis of the prism is perpendicular to vertical plane. For example, if we are picking something like a prism, maybe a box in that way. If we are looking at this kind of prism, then everything, the axis is perpendicular to vertical plane. Then what we will see is a rectangle here, and here it also maps to rectangle. So, what we will see is a rectangle in that way. Different prisms, different kind of projections. For example, let us consider pentagonal prism. So, axis is perpendicular to vertical plane. That means, when we are looking the view, the pentagon will be visible only on the vertical plane. And this is one possibility where axis perpendicular to vertical plane. When we are looking from top view, these points maps to lines like edges, and we will see that, and this line entirely from the top view again a continuous line. This one will be visible, maps there, but these points or those edges will not be visible. So, we show it by dashed lines. In case same axis perpendicular to vertical plane, but edges, it is not just resting on horizontal plane, something like this part. If we are looking, this is resting on horizontal plane, but if it is slightly inclined, maybe rotate it in that direction, only this line contact or point contact we have it. Then when we are looking from top view, this one we will be in a position to sense as an edge, this one also we will see as an edge, and this one also we will see, because this entire plane surface we will see again as an edge. And these lines we will see as continuous lines. This one, this edge is invisible, so we show it by dashed lines, and this one will be visible, so we show it by a continuous line. Similarly, if prism is prism axis is perpendicular to vertical plane and resting on one of the edge, and when we are looking at that, this entire face is parallel to horizontal plane. In that case, these lines will be visible, this one also visible, and this one is invisible line. So, invisible line is dashed line, and this entire surface we will see it as this object. So, it is a filled surface. Similarly, this entire surface we will see as another filled object, and this one as a filled object, so a continuous line. This is the way a prism we will have projections. If I would like to draw a side view of that prism, for example, from this direction I would like to visualize, then these lines maps there. This one goes to a rectangle, this one we start seeing something like that, perhaps this entire thing in that way we will see. These lines maps, so that is this one, because it is precisely located at midway. If something like midline is that one, below that we will see that line. So, this line will be more like an axis, and where we will see is here we will see that line. This is the way our left direction side if we are looking at. Now, let us take a pyramid, and its axis is perpendicular to vertical plane. So, a pyramid is a pentagonal pyramid. So, having apex, all these points are going to connect it there, and axis perpendicular to vertical plane, and one of the base is resting. So, first of all construct that pentagon in the front view, and we are looking, this is the front view. So, the entire apex cone 1 map to that point, all these slant edges maps to this point. Now, we want to look at from the top view. When we are looking from top view, these edges and the surface we will see it in that way. Now, this surface is visible, this surface is visible, and this line is also visible, the surface whatever it is connecting. So, this one, whereas these lines are invisible. These lines are invisible things. That means that entire inclined surface whatever it is coming in that direction. So, those points we will show it by dashed lines. Similarly, if the base is inclined at different directions, we will have a view in this way. This entire base we want to rotate it by an angle, and axis is always be perpendicular to vertical plane. So, point always be there. When we rotate, this line will be visible. So, that visible line is this. Anyway, edges we always see that edge coincides with that, and C edge also, whatever C to O edge, we will be in a position to visualize it there. Similarly, B to O edge, we will see that, and A to O, we will be in a position to see it from the top view. So, that one goes in that way, and all these things on the other side maps to this point. If we are looking carefully, A prime A, D prime to D, C prime to C, B prime to B, and the E prime which is at bottom of that, which is not visible. So, that is the reason we show it in parenthesis. Similarly, if this edge, one of the thing, this E prime point, if it is resting on horizontal plane, then we will see A, B, C, D points straight away in that top view, and O point they will be connected by lines. This BO line and CO line always be visible. So, we will have continuous lines. What is not visible is this O to E prime for that prism, that is the reason we show it by dashed lines. So, thank you very much, and in the next class we will learn more about this projection of solids.